Welcome to Accounting 202 Managerial Accounting at Kapiolani Community College. In this video, we'll go over Chapter 19 and 20, which deal with break-even analysis. To set the stage for break-even analysis, it's important to think about this quote from Yogi Berra, a famous baseball player. Three types of costs we'll be working with: fixed costs, variable costs, and semi-variable or mixed costs. Fixed costs remain unchanged regardless of how much you produce or your activity level, as long as you're talking about working within your relevant range of output. Relevant range of output is the level of production or activity that you can be expected to reasonably operate within. Variable costs vary directly and proportionally with changes in your activity level or your volume. So the more you produce, the more they go up. The less you produce, the less they are in total. Mixed or semi-variable costs are actually really more true to life than either fixed or purely variable. And that is so because they have an element that's part fixed and part variable. Now the relevant range can be defined as that output or that range over which our output can be expected to vary and assumptions about our cost behavior can still be valid. So here's something to take note of, and this is because it's not exactly what it doesn't come out exactly like you'd think it does. If we produce more product, then our total fixed costs will remain the same, but our variable costs will increase. And that's because we're talking about them and how they behave in terms of their definition. If it's semi-variable, the fixed part will want to go up, stay the same, but the variable part will want to go up. Now, if we look at them per unit, fixed costs as you produce more will be less per unit because they'll be averaged over more units. Variable costs, however, will be the same. In the case of semi-variable mixed cost, the fixed part will want to go down, but the variable part will want to stay the same. So these are not exactly intuitive. You might want to pay special attention to them because that's how these costs can change. Now, we're going to use the contribution margin approach, or CVP, or cost volume profit, or variable costing approach income statement to do a lot of our work. You can find these in chapter 20 and in the appendix to chapter 20. The contribution margin and the contribution margin ratio are the two most important factors that you'll use from this. The contribution margin is how much revenue you have left over from your sales or your revenue after you've covered your variable costs. So it's sales minus variable costs equals contribution margin. And the contribution margin ratio is the percentage of revenue that you have left over after covering your variable costs. So that's your contribution margin divided by sales. Now we're going to take just this tiny little bit of information like this and fill it in and get this thing to work. First of all, variable costs can't be subtracted from something until you know what the something is, and that is sales. However, we don't know what the dollar amount of sales is, but we do know that our product sells for $100 per unit. So we have a per unit, a percent, a total 1 for one hypothetical total, and a total 2 for another hypothetical total. Let's make the total 1 be what's called break-even total, meaning we won't have any operating income, but we won't have any loss either. And let's make total number 2 be one where we earn a grand total of operating income of $5,000. So to fill this thing out, kind of think of it like a jigsaw puzzle where you have some of the pieces and other pieces you still need to find. Look for the parts that fit. So the sales is going to be the largest number on our income statement. That number will always be 100% of itself. so I'm going to make it 100%. And variable costs were already defined as being 80% of the sales. Well, if I take 80% times 100 as I'm working my way down, I can multiply 80% times 100, I'll get $80. And of course the math is kind of easy on this one. 100 minus 80 equals 20. And 100% minus 80% is 20%. So now I have just about everything I need in order to generate some answers over here in the total 1 and the total 2 column. First thing I can do in total 1 is recall that operating income when I'm breaking even is 0. So my net income in this case will be 0. And the sales minus variable costs equals contribution margin, and then I subtract fixed costs and I'll get the operating income. If I'm working my way back up, I'm going to have to add in order to get the preceding numbers that are missing. So something minus 1,000 equals 0. That something must be 0 plus 1,000 or $1,000. Now to move above the black line here, I need to use division. Some number times 20% equals my $1,000. How can I get the sum number? And the sum number I'm talking about must be sales, whatever it is. So some level of sales minus variable costs for that same level must equal the $1,000 left over for me. So I'm going to go from the 1,000 straight to that level of sales. 1,000 divided by 20% will equal my sales. 1,000 divided by 20% will equal my sales. Let's check it out and see. 5,000 times 80% should be 4,000. And 5,000 minus 4,000 should be 1,000. So it's correct. This column works. Let's go from there to total 2. Let's say that we're trying to generate operating income of 2,000. What can we assume? Well, we can for sure assume that our fixed costs are fixed because that's what fixed costs are in total. And we're going to go from there up to whatever number it is that when I subtract 1,000, I get 5,000. It's not 4, it's 6. So 6,000 minus 1,000 equals the 5,000 left over operating income. Now, how do I get above here? I have to divide. So 6,000 divided by 0.2 or 20% tells me my sales. In this case, that sales is $30,000. And that goes right up here. So the only thing left to do here for this column is to figure out how much variable costs are. 30,000 times 80% is 24,000, or 30,000 minus 24,000 equals 6,000, so that works too. Now there's two pieces of information missing, for one for each item. For total number 1, there must be some certain number of items that I'm selling that's going to lead me to this, and there's an easy way to compute it. The contribution margin in dollars divided by the contribution margin per unit in dollars will tell me how many units we're talking about. So I can take $1,000 contribution margin and divide by $20 contribution margin per unit, and I'll get the number of units that I'm talking about, which in this case is 50 units. If I look at total number 2 with my generated income of $5,000 and I take a look at that contribution margin of $6,000 here, that $6,000 is made up of however many units I sell times $20. So again, the same computation, $6,000 divided by $20 equals 300 units. So the number of units number of units required to break even is 50, and the number of units of sales required to generate operating income of $5,000 is 300. So we can take that layout and you can do cost, volume, profit analysis. You can play around with it and see if I need to generate a certain level of income, what kind of sales should I have, variable costs, and contribution margin. So the quick way to get what we did, once you understand how it works, is to take the fixed costs plus the operating income and then divide that by the per unit contribution margin. In other words, take the desired contribution margin and divide it by the dollars of contribution margin, and we'll get the how many units is required in order to reach that level of income. In this case, 6,000 divided by $20 is 300 units. So you divide by dollars, you're going to get the number of units. If, however, you divide by percent, you're going to get dollars. So in this case, the fixed costs plus desired operating income here, 5,000 operating income, fixed costs 1,000, gives me 6,000 desired contribution margin, divided by 20% will give me the 30,000 that I need in sales. So you divide by dollars, you get units required. You divide by percentage, you get dollars required. We're going to look at the margin of safety. The margin of safety is how much your actual sales, whatever they may be, exceed the break-even level of sales. So in this problem here, any amount of sales more than 5,000 will be above the break-even level of sales. So whatever that number is minus 5,000, that actual sales number minus this break-even sales number of 5,000 will give me my margin of safety. So let's say it's 37,000 in actual sales. My break-even level of sales is 5, so I'll have a margin of sales of 32. The interesting thing about this is you can take that margin of safety times your 20% contribution margin ratio and get the profit that I'm going to produce. 32,000 times 20% will give me $6,400 of income. So if you were to plug the 6,400 into this table up above, you would see that 6,400 minus its associated variable costs will equal the contribution margin, then minus 1,000 will give me a leftover amount of income of 6,400. So the higher your contribution margin ratio, the faster your margin of safety sales will make your net income grow. The margin of safety ratio is the margin of safety, dollars, divided by the related amount of sales. That's your margin of safety ratio. This tells you the percentage decline in sales you could handle before going and slipping into a net loss. An interesting concept related to this is something called operating leverage. Operating leverage looks at your total contribution margin at some given level of sales, then divided by a given level of net income, and that tells you your degree of operating leverage. In this case right here, our fixed costs are quite low. They're only 1,000 out of the 5,000, or down around 20%. So if we have an operating leverage of 1.16 and we produce more, our income will rise, but not that quickly, not as quickly as if we had a higher operating leverage. Now, when your underlying dollar amounts change between what you're given and possible scenarios, you have to change the basic amounts used to do your computations. So be on the lookout for that. There are some problems that deal with that. Now, sales mix is a more realistic situation, closer to real life, than the single product scenario that we've been looking at up till now. And in this situation, you have multiple products or items for sale, and they have to be given, or you have to be told how much of each one there is, or you have to make estimates of two important things: each item or class of items per unit's contribution margin, and each item or class of items percentage of total sales. In other words, what percentage of my sales is it? That's called the sales mix percentage. You can no longer work with individual unit contribution margin ratios because they have to be combined and integrated in terms of how much you think of sales that product will contribute. And then you'll get the weighted average unit contribution margin. So let's say we have item number 1 that has a per unit contribution margin of $25, and we're going to say it makes up 70% of our sales. Just take the $25 times the 70% and get this number over here, $17.50. Then for item 2, which has a contribution margin ratio of $40 but makes up only 30% of our sales, take the $40 times the 30% and get this number over here, $12. Add the 2 weighted average contribution margin, $17.50 plus 12, and you'll get $29.50. And you can use $29.50 essentially to do problems just like these up here. It just becomes your new contribution margin ratio, but you're unable to work with individual per unit amounts because you're going to be dealing with only the mix. If you have a situation where you're trying to determine how to optimize your profit and you have limited resources to work with, which is pretty frequent, then you need to look at whatever resource it is that's constrained that limits your production capability in order to figure out what's your best course of action. And to do this, you need to compute the contribution margin for per unit of your constrained resource. So if that's factory time or labor time or whatever it is, and then allocate as much of your production as possible to the product that has a higher contribution margin per unit of that constrained resource. You may be forced, however, to have a minimum number of hours of production that's the lower margins type, or there may be a limit on the absolute amount of the resources available for the various kinds of products. So depending on the scenario, this may or may not be possible to allocate all of your production to that higher contribution margin per unit of constrained resource. To come up with numbers that will work inside of our CVP process that we've looked at so far, we need to really turn them into purely fixed and purely variable numbers. And to do that, we can use this method called the high-low method. Now, to use this in CVP or cost volume profit analysis, you have to break up your mixed costs. So the first thing is to pick the highest, look back over a table of activities with the amount of our costs and our activity level, associated activity level, and then pick the highest cost that you've had and that related activity level, as well as the lowest costs you've had and their lowest activity level. So the highest cost minus the lowest cost will be your change in total costs. And the highest activity minus the lowest activity will be your change in activity level. When you take the change in total cost, divide by the change in activity level, that'll give you variable cost per unit. So take your mixed cost at that highest level and compute variable costs for that level of production, and that will give you your variable cost per unit. And take the highest mixed cost minus that variable cost per unit, and that'll give you the fixed costs. That should work at both the highest end of the spectrum and the lowest end. As long as that works, then you can use the formula to compute your total mixed costs. Let's try one here. Let's say that Dollywood Corp accumulates the following data concerning a mixed cost using miles as the activity level. So miles driven in January was 10,000 and total cost 16.5, all the way up to April. miles driven $7,000 and $12,000 cost. We'll start out with the highest activity level in terms of dollars, 16.5, and total cost lowest possible, 12,000, and the highest number of miles driven, 10, and the lowest number of miles driven, 7. So 10 minus 7 is 3, and 16,005 minus 12,000 is 4,500. So 4,500 minus 3,000, divided by 3,000 equals 1.5, or $1.50 variable cost per mile driven. Let's test it out. At 10,000 miles, it'll be $1.50 times 10,000, that's 15,000 variable cost portion, plus the fixed portion of 1,500. Let's make sure the 1,500 like that works over here. If we take $1.50 per hour or per mile variable cost times 7,000 units on the low end, and then we add the $1,500 fixed costs, we get 12,000. So this one works also. So we've used the high-low method to come up with the expected dollar amount of our mixed costs, which consist of fixed and variable portion, by applying the high-low method. Hope this helps. Thanks.